All right, so this one doesn't look too bad other than it's got that kind of gross 3/4 in the exponent. Trying to solve for x. So the first step seems pretty straightforward, is to move that over. So now if I add 14 onto that 13, I've got 27. It's the next step that now to get rid of that 3/4 exponent. If you remember, powers to powers are multiplied. So if I take this whole side and raise it to the 4/3, so that the 3 times 4 is 12, the 3 times 4 in the denominator is 12, 12 over 12 would be 1. It's like it cancels it. So I'm going to raise this to the 4/3, so I got to raise the other side to the 4/3. So then the left side is just x squared minus x minus 9, because these end up being just 1. So the exponent is 1 here on this whole thing if you wanted to. It makes it look more complicated to me though, so I'm going to leave it off. And now on the right side, remember the denominator is a cube root. So this is like I'm saying the cube root of 27, and then I'm going to put it to the 4th power. Well, what number multiplied, if you have that number 3 times, it's going to give you 27. That's 3 to the 4th power, and then, so there's 3 to the 4th. The way I do this is, that's 9, that's 9, so this is going to be 81. So now my next step, if I subtract this 81 over to this side, is that not 90? Negative 90. And then I'm thinking this factors again. So how about x minus 10 and x plus 9? And then when you set each factor equal to 0, when does x minus 10 equal 0? Add the 10. Or when does the x plus 9 equal 0? Subtract the 9. So 10 or negative 9. I would suggest it's another one of those that makes me think, could it have an extraneous solution? Is it possible that only one of those is the solution? Depending on if you want to substitute it in like I did on the last problem. I'm just thinking of jumping over to Desmos again and see if there's only one solution or more. So if I go over there to Desmos, oops, that's not Desmos. Sorry, I'll get it here eventually. So I've got this x squared minus, oops, x, hello, jumping all over the place here, sorry about that, minus 9 into the 3/4 power, and then I'm going to move that to the other side so that I'm looking for where this whole thing, oops, I'm missing a number in here, minus 9 equaled 27 when we move that over. So looking for our solutions here, if I get up there where I can see the 27, it does indeed look like it probably has, oops, I didn't put a y equals 27. So my two negative 9 for the x and a positive 10. And if I'm not mistaken, that's what we came up with for our solution there. So that must be correct.